spend the next 2 lessons doing this. So today you might be a bit confused. I'll give you a couple of questions to try. We will spend tomorrow's lesson together just practicing lots of questions on this because it's one of those topics which really you can't do unless you just do lots of practice. All right, so bearings are like a compass point, okay? So we need to, and I want you guys to get in the habit of all the time just drawing this sort of crosshairs, you know? All right, so what direction is the arrow going in?
North.
North. All right, what direction is the next arrow going in?
South.
South. What about this one?
West.
West and east. Now, how many degrees are there in each of those quadrants? 90. So if we start, sorry guys, if we start at 0, east will be 90 as we go clockwise. South will be 180 and west will be 270, okay? We don't usually go 360, so we usually go about to 359. I need you to stop talking, please. Now, there are 2 ways to describe bearings, and you need to know both of them because they are interchangeable. The first way is using 3 digits. So it goes from 0 to 360, and really if we're going to use 3 digits, it should be 0, 0, 0. These are called true bearings to 360, okay? And they are just from the north point all the way around. Okay, so if I had 190 degrees, where would that line be? So it would be just west of south, yeah? So if I start at south, I'll be just moving to the west a little bit, or south, southwest would be fine. This would be 190 degrees. And that would be how we would say 190 degrees. We'd write it like that. Okay? So that's the 3-digit way. It's always clockwise. It's always clockwise from north. What's wrong? Because it starts at 0 north, and then we go 90 to the east, 180 to south, so 190 degrees from the north point is in that direction. It's just past the straight line. Pardon? Oh, so that's the range of the different bearings you could have.
Yeah, I just forget how you get 190.
All right, so no. So I'm just saying that 190 is this one. E.g., how about this? Is that better? For example, that's 190 degrees.
Oh, okay.
Okay, that's all right. That's me confusing. No. So I'm saying the range is from 0. So that's okay. I didn't explain myself very well. Pardon? Yeah, so 190 degrees is always going to be 190 degrees from north. That's where it's going to be. Now, how did we describe it then? Like I asked you to tell me where it was and people said south and west, okay? So the other way is with directions. So it's about the directions within a quadrant. So the angle's always going to be less than 90 degrees. And what you do is you say where it starts at, how many degrees you're moving, and where you're moving to. So for this, I'd say I'm going to start at south. I'm going to move 10 degrees towards west. And that's going to be exactly the same thing. So I could describe this bearing as 190, as 190, or I could describe it as south 10 degrees west, because starting at the south line, I'm going to move 10 degrees to the west. Is there another way I could describe it? No?
Start at west.
If I start at west, I'm going to move 80 degrees to the south. Same thing. Oh, it disconnected. It's telling me that too. Okay, so could you write down west 80? So W80S. From the west, go 80 degrees to the south. Can someone tell me the number, please?
328 347.
Sorry. 3, 2, 8, 3, 4, 7. Thank you. All right, so you could write this way. So south 10 degrees west or west 80 degrees south. They mean the same thing. Directions with a quadrant. Within a quadrant should be. Okay, so we can look at different things. So, Gabby, if I put up this line here and I said it is west 20 degrees north, can you give me another description of that bearing? Perfect. Because if we actually do the 3 around towards 360, we got to 270 and then we went 20 degrees further, it's also 290 degrees. Can someone else tell me a different way to get there? Another way? Yep, flip. Perfect. So from north, 70 west. So there's lots of different ways of being able to describe bearings. Because if I start at north and I go 70 degrees towards the west, that's where that bearing's going to be. All right? Okay, so we need to have bearings questions will always be with trig, okay? So when you get given a bearings question, I'm just going to give you a couple of quick tips before we try and remember some things. Question? Why is it north 70 west? All right, so if you think about it, we start at north and then we go 70 degrees to the west, it brings us to this line. But the other way is we could also, instead of starting north, we could start at west and then go 20 degrees and we'd still get to the same line. So there's 2 different ways of describing, or 3 different ways of describing it. Does that help? Yeah. All right. So some tips for bearings questions before we start. Step 1, draw the pictures. So draw the bearings carefully. Okay, so you always need to draw them out. Include a north point, or at least a north point. I would actually include the whole quadrant. So I'll show you. It just means this. Draw that at each point.
So draw the whole thing instead of just drawing one point.
Yeah, because I'll explain what I mean. So make sure you draw that at each point. It's going to help you. Make sure your picture includes a triangle. So the story should end up with you having a triangle in your working out. Otherwise, you're not going to be able to use trig to work it out. Three, try to fill in as much info as possible. Remember, alternate angles are equal. I'll explain what that means in a second. Use trig to solve. Now, for all of the questions we do in the next 2 days, the answers are going to have right angle triangles in them. So we need to find a right angle triangle for some of them too. All right, so what I mean by include a north point or a quadrant at each point is if I have 2 points here and I put in a quadrant like that, and then I have another point here and I put in a quadrant like so, north, north. What can you tell me about those 2 north point lines? They're parallel, okay? Because north always is going to be parallel with north, we can end up using some different rules. Now, if I know that this angle here, so if I say that this point was, let's say, 20 degrees, okay? So this, if I actually was describing this, I would say point B, it's approximately, yeah. It could be a bit closer to 30, but it'd be close to 20. Okay. So point B is, I could say point B is on a bearing of, what would the 3-digit bearing be for this? From A. 110. So I could say is 110 degrees from A. Or I could say is on a bearing of east 20 degrees south. Or I could say is on a bearing of south 70 degrees east. They all mean the same thing. Okay? Can everybody see that? Because it goes from 0, it goes 20, it's got the 90 here. So it's on a bearing of 110 degrees, or it could be described in the other ways. Now, what I should know, because of alternate angles being equal, if I've got parallel lines and a line crossing over them, it means that the angle on the other side of the line, of the transversal of that bearing, is going to be exactly the same. So it means this angle here is going to be exactly the same as this angle here. So what angle is it going to be? 20. That always works, okay? So if we look at the angles made within those quadrants, we're going to know that those angles are the same because the east-west lines are parallel and the north-south lines are parallel. So therefore, what does this angle here end up being? 70, because each quadrant's worth 90 degrees. And so therefore, what angle is this one as well? It's also 70 degrees. Okay, so when I say draw the bearings carefully, include a north point quadrant, that's that point, that's those lines I'm talking about, because it's going to help you to be able to work out the rest of the angles. When I say make sure your picture includes a triangle, that's about your drawing at the end. Try to fill in as much information as possible means that we can actually fill in those 20s and those 70s to be able to work out an answer. Now, this question doesn't have a triangle. It's just a line. I'm just trying to show you the information. Okay, so alternate angles are equal. So you can work them out as we go. All right. So as I said, the best way to do this is to show you using an example. We're going to work through one example today. I'm going to give you one question to do at home, and then we're going to do a heap of practice tomorrow. Okay, so if you still don't understand today, that's okay. If you still don't understand tomorrow, that's not, and that's why you need to ask lots of questions tomorrow, okay? But let's go through this together. So we are going back to exercise 10. I'm just going to use a question from the book. All right. Okay, this is exercise 10B, question 9. This is the sort of question you'd get in a test. From ship A, ship B, I need you to write this quite quickly because we're going to run out of time, lies 12.2 kilometres away on a bearing N58 degrees west. From ship B, guys need to be writing, not talking. From ship B, ship C lies on a bearing south 32 degrees west. If the bearing if you want to read it in your book, it's exercise 10B if you don't want me to listen. If the bearing of C from A is S 59 degrees west, how far is ship C from ship A?
Yes, 58.
58. N 58 degrees west. All right. Anytime we get given a worded question, we want to highlight the most important bits. So from ship A, ship B lies 12.2 kilometres away on this bearing. From ship B, ship C lies on a bearing of this. If the bearing of C from A is 59 degrees here, how far is ship C from ship A? So when we draw this, I want you to just do a dot for each thing. So I'm going to start with ship A and go, okay, I'm going to do my north point and I'm going to write A, this is ship A. Everyone okay to there? If you draw that crosshairs, the bearings there, it's going to make things easier for you.
But you have to know what is an A.
I'll just label it as A because it's going to keep your mind in the right mindset as you're going. Yeah, so anywhere, wherever you can fit it. So it says lies 12.2 kilometres. Now I need to remember to write that down after I've drawn my line. On a bearing of north 58 degrees west. So from the north, I'm going towards the west 58 degrees. It doesn't need to be perfect. Give yourself some space. Don't make them tiny because you don't know how much you're going to do. So 58 degrees. What's wrong? From the north, we're moving. It's all right. Just only use half your page. It's okay. So I'm then going to do a point and I'm going to do the crosshairs again. Later on, I'm going to fill in more, but I know the 58 and I know 12.2 kilometres. Yeah? Is everybody okay to there other than that they might not have had enough space on their page? Okay, and this is point B. It's all right. Yeah. All right, so then it says from point B to ship C lies on a bearing of south 32 degrees west. So from the south, 32 degrees to the west means we're going down this way. Now, where most people go wrong with this is they don't know how far, whether it's below or above to get to A. So don't stress about it. We use a pencil so we can edit it if we need to. From ship B, this is ship C. Okay. Now, if the bearing of C from A, so we're now connecting up C to A, or I better not draw it that way yet, is south 59 degrees west. South 59 degrees west. That means I need to actually make this a bit lower. So that's why I said use a pencil. South 59 degrees to the west means our triangle looks a bit more like this. So we've got that 59. How far is ship C? Guys, I really need you to, I know that you're laughing about your drawings and stuff, but I need you to focus. We're asking how far is this from this? Have I drawn a triangle? Yes, okay. So what's the first question whenever we solve anything for triangles though? Is it right angled? So one of the things we want to do is put in as many angles as we know to be able to work out if it's right angled or not, because then we can work out what rules we're going to use. So what if I know right now I know this 58 degrees. Is there anywhere else where this 58 could actually impact on? Where? Up the top, good. So this angle here is also going to be 58 degrees because they're alternate angles. Can everybody see that? Now, what do those two angles together make? Say it. Did you say it? No? 90 degrees. So we have a right angle, which means what rules can we use? SOHCAHTOA, Pythagoras, half base times height. Yeah? All right, it's a very big right angle, but you know what I mean. All right. Now, we have another bit here. Do we know what these angles are on the right-hand side? Yeah. Okay. What is it? So if you've got 59 here, what's this angle here going to be? 31. And what's this angle here going to be if the other one's 58? 32. So in total, this angle is 63. Well done. All right. Now, that's pretty much most of the information we can find out. However, I find this really, really confusing. I would much rather turn it around, make it a triangle and go, okay, I've got a right angle. I've got 12.2 kilometres here. I've got 63 degrees, and the hypotenuse is what I'm trying to find. And suddenly my bearings question becomes a way easier because it's just a SOHCAHTOA question. You don't have to redraw it if you don't want to, but I find that a lot easier. Yeah, so you can just leave it as you go, but just make sense of it yourself, okay? So once I've got this, is it a right angle triangle? Yes. What therefore is the x? What side is it? Hypotenuse, 12.2. Adjacent, so what rule are we going to use? Cosine, so cosine 63 equals 12.2 over x. If the x is on the bottom, what do? Switch it. And we get our answer. Someone's going to put it in their calculator for me. 26.9 kilometres. And so you'd say C is 26.9 kilometres from A. So the hard bit of this is working out what all the angles are and drawing the picture to start with. I would like you to practice by doing question yeah. All right, can you try to do question 7? I'll just give you question 7. Just question 7, exercise 10B. And we'll practice a heap more tomorrow. 10B?